Example 2 says, determine if the following triangles are acute, right, or obtuse. So to do this question, we're going to flip back to the page before, because right at the bottom says theorem 9.4, if the sum of the squares of two shorter sides of the triangle is less than the square of the longest side, then the triangle is obtuse. Theorem 9.3 basically says if it's acute. And so from that, this right here is key. You need to make sure that you understand this right here. So if the square of the legs, sum of the square of the legs is equal to the hypotenuse, you know that's a right triangle. If the sum of the square of the legs is greater than what would be the hypotenuse, then that's an acute angle. And if the sum of the square of the legs is less than the hypotenuse, what would be the hypotenuse, then it is obtuse. So that's what you need to make sure that you know and memorize and are very familiar with that. So let's take a look at this now. For number 2, A, our longest side would be our quote, would be our hypotenuse. So if I have 6, 3 square root of 5, and 8, my longest side there is going to be 8, because the square root of 5 is equal to, it's less than 2, or just a little bit over 2. So let me get out a calculator here and say the square root of 5 is, good grief, I'm trying to find it on this calculator. This is interesting. Here it is. Good night. It's 2.2, and if I multiply that by 3, that gives me 6.7. So 8 is my longest side, so I'm going to say a squared plus b squared is equal to c squared. I'm just going to start out with the Pythagorean theorem and then evaluate it when I get to the end. Okay? So when I do that, I have 6 squared plus 3 square root of 5 squared is equal to 8 squared. So 6 squared is 36 plus, now 3 squared is 9. And the square root of 5 squared, as we've seen before, square root of 5 times the square root of 5 is the square root of 25, which is 5. So 9 times 5 is 45. So this is 45 is equal to 64. So 36 and 45 is 81, and this is 64. 81 is larger than 64, so the sum of the square of the legs is greater than my quote hypotenuse. So then this would make an acute triangle, because the sum of the square of the legs is larger than what my longest side be, or what would be the hypotenuse if it were a right triangle. Let's take a look at B. Now, just because it looks like it's a right triangle, and you're like, oh, well, that looks like it could be a right triangle there. If it doesn't have the marking for perpendicular, then we know we can't assume it's a right triangle. So we're going to say 15. So again, I'm using the Pythagorean theorem. A squared plus b squared is equal to c squared. We want to know if it's equal to, less than, or greater than. So then I'm going to have 15 squared plus 14 squared is equal to 21 squared. I'm going to put a square there. So 15 squared is 225 plus 14 squared is 196. And is that equal to 441, which is 21 squared? So if I add 225 and 196, that gives me 421. And my other number is 441. So 421 is less than 441. So my sum of the squares of my legs, my two shorter sides, is less than the longest side. So then this is going to be an obtuse triangle. And that is how you do those. Make sure that you guys look over on the other page how to tell whether it's obtuse, acute, or a right, and kind of memorize that so that You guys know what you're doing on that.